By 2030, a jet strikes a target from 1,500 kilometers away. The enemy radar never registers the incoming threat. This stealthy approach will soon be the standard protocol for air combat. Welcome back. Today, we're taking you inside the most ambitious and complex software upgrade in aviation history. If you enjoy deep dives into military technology, make sure to hit that subscribe button. Right now, the F-35 fleet is undergoing Technology Refresh 3. It is essentially open-heart surgery at 35,000 feet, installing an entirely new computing brain. This schematic represents that new core. It delivers 25 times the processing power of the older system. That leap in computational muscle feeds new panoramic 3D cockpit displays and fills expanded memory units capable of handling terabytes of mission data. Without that raw processing headroom, the F-35 cannot run the advanced artificial intelligence and sensor fusion algorithms required to survive in airspace defended by modern, near-peer militaries. Replacing a jet's computing architecture while maintaining full-rate assembly line production is incredibly complex. Throughout 2023 and 2024, software validation delays and chronic stability deficiencies created a massive bottleneck, bringing deliveries to a complete standstill. Over 100 brand new F-35s, worth $10 billion, accumulated in storage because their code refused to cooperate. To break the logjam, the Pentagon accepted a compromise, delivering jets with truncated TR-3 software limited to basic training, rather than full combat deployment. The implication is clear. Military readiness is no longer determined by how fast factories can assemble metal and composite materials. It is dictated almost entirely by software stability. The Block 4 weapons package requires the TR-3 computing foundation to function. Currently, an F-35 can only carry 4 AIM-120 AMRAAM missiles internally if it wants to maintain its stealth profile. Engineers developed a new internal adapter called Sidekick. This rack shifts the existing layout, increasing the internal payload to 6 missiles. That puts the F-35's magazine depth directly on par with the F-22 Raptor. Magazine depth is only one part of the equation. The U.S. military is also developing the highly classified AIM-260 Joint Advanced Tactical Missile to directly counter the long-range PL-15 missile fielded by China. In the vast expanses of the Indo-Pacific, the Chinese PLAF relies on its J-20 stealth fighter to launch the PL-15 and dominate aerial engagements from immense distances. This radar map illustrates the distance problem. The inner circle shows the current AIM-120. The outer circle represents the AIM-260, which pushes engagement distances out to at least 200 kilometers, comfortably outranging the PL-15. Block 4 also integrates the long-range anti-ship missile for coordinated maritime swarms, the Stormbreaker smart bomb for all-weather precision, and the AARGM-ER to hunt down and destroy enemy radar sites. By combining these tools, Block 4 turns the F-35 into a beyond visual range sniper, allowing it to engage an entire enemy squadron while remaining completely invisible on radar. Historically, NATO has relied heavily on dedicated electronic warfare aircraft, primarily the U.S. Navy's EA-18 Growler, to jam enemy signals and protect strike packages. TR-3's processing power allows the F-35 to handle this workload internally. The jet can project its own electronic shield, blinding enemy radars and generating dozens of false targets without relying on bulky external jamming pods. However, to effectively counter a radar, the aircraft must know exactly what signal to look for. This requires a digital threat library. If an enemy system switches to a new, unrecorded war mode frequency, the jet's sensors might fail to identify it. We saw this early in the war in Ukraine. When U.S. F-35s patrolled the borders, their systems occasionally failed to correctly identify Russian S-300 anti-aircraft batteries because those specific war mode signals weren't in the database yet. Block 4's open architecture directly addresses this bottleneck, allowing technicians to update mission data files rapidly. As Russian and Chinese radar tactics evolve, the F-35 fleet can receive new signal profiles in near real time. Equipped with this electronic warfare suite, the F-35 acts as an invisible orchestra conductor, suppressing incoming threats and actively shielding nearby friendly aircraft. The base F-35A costs $82.5 million, but munitions and support push a combat-ready unit to $120 million. Partner nations who funded early development receive significant discounts. The headline $2 trillion lifetime cost stems from extending the aircraft's service life to 2088. Operating any combat platform for over 6 decades is expensive, but consolidating the jobs of interceptors, bombers, and electronic warfare planes into a single stealth airframe proves far more cost-effective than maintaining separate fleets of aging, vulnerable fourth-generation aircraft. Ultimately, air superiority is about information dominance. The TR-3 and Block 4 upgrades transform the F-35 into a flying command node, capable of directing an entire theater of war through networked intelligence. Thanks for watching. If you found this breakdown helpful, please like the video, share it with someone who loves aviation,